Hey guys, in this video we will be going over how Bitcoin operates in more detail and also go over some terms that are commonly used in Bitcoin and blockchain in general. So Bitcoin protocol is just a list of rules on how entities can interact on Bitcoin network. There are three main entities known as the wallet, full node, and miners. We will go through how a transaction is initiated and confirmed on the Bitcoin network. We have Jenny here again, trying to send 0.5 Bitcoin to John. Jenny will use a computer program known as a wallet. There are now several different wallets available, but she decides to use one of the more common ones known as the Ledger Nano. Using the wallet, she creates a private key that only Jenny knows, which is associated with a public key. The private key can be run through a hash function, and she can obtain her public key. You can always convert your private key to a public key, but you can never go the other way around. The input for a Bitcoin's hash function can be any size, but it will always return an output of random numbers and letters that is 256 bits in size. The hash function will always have the same output for a given input, but even a small change in the input will result in a completely different output. This hash function is one of the most integral parts of Bitcoin and blockchain in general. And hash functions are based on cryptography, hence the name cryptocurrency. The name cryptocurrency is somewhat confusing as it seems to suggest that these digital currencies, such as Bitcoin and Ethereum, operate under a shroud of mystery. However, cryptocurrency is probably the most transparent way of storing data since everyone has access to the data and anyone can get real-time data on which addresses are exchanging Bitcoin. Continuing with the transaction between Jenny and John, Jenny will use the wallet to create a transaction. The transaction contains the amount of Bitcoin Jenny wants to send, John's public key, and a signature. A signature is created by passing Jenny's private key, amount of Bitcoin, and John's public key through the hash function. This transaction is sent to a random full node. A full node is also a computer program that lives on computers all over the world. The full node can use the signature to verify that the person that sent the transaction is actually the person that owns the private key. The full node also holds a copy of the entire blockchain and looks at the blockchain to verify that Jenny has a balance greater than the amount she is trying to send. Once the transaction is verified, the full node sends the transactions into a pool of other transactions waiting to be added to the blockchain. At this point, miners all over the world provide computing power to the network. The miner groups a bunch of these transactions into a block. Then these miners run a software designated by Bitcoin to solve a difficult mathematical puzzle. The faster the miner's computer is, the more likely the miner will solve the puzzle. When the miner solves a puzzle, the miner is awarded a certain number of Bitcoins and also takes a transaction fee. The current award is 6.25 Bitcoin, and this number halves every so often until the maximum number of Bitcoin has entered circulation. The maximum number of Bitcoin that will ever be created is 21 million, and at the time of making this video, about 18 million Bitcoins have been released. To increase their chance of winning, miners create mining farms where they aggregate a bunch of fast computers in an area where electricity is very cheap. The protocol is designed for a miner to win about every 10 minutes. So when more and more people contribute computing power, the puzzle becomes harder and harder to solve. This is one of the biggest criticisms of Bitcoin because the network consumes so much electricity to solve these complex but essentially useless puzzles. This is also the reason that sometimes takes a really long time before a transaction is confirmed, because a block of transactions is added to the blockchain every 10 minutes. But moving on, when the miner finally wins by solving the puzzle, the miner sends the block of transactions back to the full node and the full node adds it to the blockchain. The concept of requiring miners to solve a problem to update the blockchain is known as proof of work, and it helps protect the blockchain from malicious attacks. Once added to the blockchain, the full node transmits these changes to all the other nodes so that all the other nodes can update their blockchain, and all the full nodes can once again be in consensus. And the blockchain now shows that John's public key is associated with 0.5 more bitcoins. The steps to confirming a transaction may seem very unusual and inefficient, but each design choice was to create a system that is sensorless and decentralized, meaning that Bitcoin was designed so that any person in the world can interact with the Bitcoin network and does not need to rely on a centralized third party such as a bank to create trust between two random people on the internet. In the next episode, we'll discuss other cryptocurrencies and how they differ from the Bitcoin protocol.